forgot to hit record before we started. Real quick recap. Law of sines is proportions. It's ratios. You have to remember that capital letters are the vertices or the angles. Lowercase letters are the sides. Law of sines and cosines is when it's an oblique right triangle, or excuse me, an oblique, not a right triangle. Okay, so we don't have a right angle, so we can't use right triangle trig. So in this example, I sketched and wrote in pink the given pieces. Solve the triangle means find all the missing parts. So we need to find angle B, side A, and side B. Okay, so I see that I know angle and side C, and I know angle A, and I need side A. So I know 3 of the 4 pieces for this proportion. And so I've plugged in the 3 that I know. Now, how do I solve a proportion? Yeah, cross multiply, butterfly method, however you want to think of it. So we're going to cross multiply. So we're going to end up with A times sine of 20 equals 12 times sine of 45. And then what are you going to have to do to get rid of this sine of 20 to get A by itself? So for this first one, I'm showing the cross multiply and then divide. I think y'all are comfortable enough, or eventually you will be after a couple of examples, that you won't have to show this every time. You'll be able to go straight from here to saying A equals 12 sine of 45 over sine of 20. Multiplying the 2 known that are across from each other, dividing by the 3rd known, right? So y'all can eventually skip this step and go straight from here to here in showing your work. So now it's a calculator problem. What mode does our calculator need to be in? Okay, so I need to be in degree mode, and I already forgot what it was. 12 sine of 45. Now here's where it really matters that you close those parentheses that automatically open. Up to now, it hadn't really been an issue because it was the end of your problem a lot of times, and so there was nothing after it. But we have something else to type in. We have divided by, and if I don't close that parenthesis first, I'm going to get the wrong answer. So make sure you're closing the parentheses after your when you hit those trig buttons. Okay, so I'm going to calculate that. And we're going to go to thousandths. So this is going to be 24.809. All right, 1 down, 2 to go. What is the next easiest thing to find in this triangle? Or what was probably the most, but we didn't do it first? Yeah, angle B. Angle B is super easy to find right here because why? Yeah, we know that the 3 angles of a triangle add up to 180. The triangle sum theorem says our 3 angles total 180 degrees. So I know that I've used 45 and 20. So I've used 65 degrees. What's left for angle B? So the measure of angle B is 115 degrees. All right, 2 down, 1 to go. All that's left to find in this triangle is side B. Now, I have 2 possible ratios I could set up, 2 possible proportions. I could set up B with A because now I know both of A, right? Or I could set it up with C. Which one do you think's the better option? Why? Yeah, because those are given. We know those are correct. And they're whole accurate exact numbers. If we use A, we had to calculate that. So there's a chance we made a mistake and then we're using a wrong answer to find another answer. And so it would definitely be wrong. Also, because it's a rounded value, it's not the exact value. So that would throw your final decimal off a little bit. Okay, so always use the given information instead of information you found when possible. All right, so I'm going to set up sine of B is to side B as sine of C is to side C. Okay, so that is 115. Now, I am having to use the fact that I found 115, but at least that's a whole number, exact value. And I would imagine you're less likely to make a mistake with adding and subtracting than with doing proportions and trig. So it's still, you had to use that anyway, because side B is what you're looking for. All right, so C was 45? No, was C the 20? 20. And the side was 12. So I'm not gonna show the actual multiply and then divide. So I'm just gonna go straight to, I know B will be 12 sine of 115 over sine of 20. Is everybody okay with that? Now I know this is a lot of working with different trig functions, and a mistake that I sometimes see people make is saying, oh, these signs cancel out, get rid of those signs, and then they just try to do 12 times 115 over 20. That's not how this works. Sine is not a number. It can't just cancel out. It's an operation. This is sine of 115 and sine of 20. Those are not the same thing. You cannot reduce those. You have to take the trig function first before multiplying, before dividing. Does that make sense? So don't make that mistake. But your calculator will do that work for you if you type it in correctly. So it is 12 sine of 115. So you close that parenthesis, divided by sine of 20. So that comes out to approximately 31.798. So we solved the triangle. Now we know all the parts of the triangle, all three angles, all three sides. Does that make sense? Do y'all kind of remember this from geometry? Okay. All right, so the next one, we're going to set up the same way and figure out what we need to solve for first. So I am given that angle A is 39, side A is 10, and side B is 14. Actually, we're going to get cut off in the middle of this example, I think. So before I start it, I do want to look at one thing right here. This where it says when. This is when do I use law of sines? Okay. Remember back in geometry when y'all did worked with triangles and you did all this side, 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 angle, side, angle, side, angle, side, angle, angle, side, all that stuff. So you need to look at what's given here in pink. How would you, what three would that be and in what order? Angle, angle, side, right? It's not angle, side, angle, because the side that's given is not in between the two given angles. So it's angle, angle, side. That is one of the instances where you will use law of sines. If you're given angle, angle, side in an oblique triangle, you can use law of sines to solve the triangle. Okay. What am I given here in this one? Side, side angle. Okay. I'm going to not write angle, side, side. I'm going to write it backwards, side, side angle. Okay. And I am going to put an asterisk by this one because this is a special case. It's going to solve the same way. And we're not going to get to it in this. So this will be part of the video notes that you'll watch on Monday. I'll have this explanation of why we're putting an asterisk there, and then we'll have law of cosines. But we'll go ahead and try and see if we can get any parts of this solved before the bell. All right, so I know A, both angle and side, and I know one of B. So that's what I'm gonna have to start with is A and B for my proportions. Okay, so that is sine of 39 is to 10 as sine of what is to 14. So when I do my cross multiplying, I end up with sine of B equals 14 times sine of 39 over 10. Is everybody okay with that? Now, when I calculate that, is that my answer? Is that my angle B? Why not? I still have sine over here. That's when I calculate this, that's sine of B. That's not just B. What did we say in right triangle trig we had to do to get to solve for the missing angle? So we're going to have to do inverse sine of all that. If you want to do it in two separate pieces in your calculator, just be sure you use the exact decimal, like you copy and paste it. Don't use a rounded answer in the middle of a problem because then your final answer is further off. Your decimal will be off. Okay, so I would prefer to do it all at once. I would say inverse sine of 14 times sine of 39, close that parenthesis, divided by 10, and then close the inverse parenthesis. So that's how I would do it all at once to get my answer. So 61.769. Then you would be able to find the other remaining parts. So I'll stop this video here and I'll do a second video. That's what you're going to watch on Monday to finish these notes out.